Chris, Ioannis, do you want to say a few words about what you do, KSN, for the CMS analysis experiments? And we'll start with this.
Yeah, so I'm one of the NGT fellows on CMS, working on various F1 trader algorithms. I'm moving now more into this kind of MLOPS side of things, so I guess that's where this workshop happened. It's kind of started out as the conversation with the Maciej development there.
Yeah, and I'm Ioannis and also an NGT fellow, but working on the Atlas tool package. Basically, this came because the target hardware for what I develop is the Level 0 Global, which is a hardware trigger component for Atlas. So we all kind of sat together and we said, oh, maybe we have common issues we need to be discussing. And I think we kind of felt like the NGT is the right framework for this. And that's why we went for that.
So maybe to put some context, easy to your answers. Why is machine learning becoming more and more important in the trick systems of its experiments? I knew we start with this and then
It's quite a difficult question.
anyone can take this one.
Yeah, I suppose what's nice about machine learning algorithms is that in some way they kind of lower the barrier to entry for a lot of our kind of work. So instead of having to be this VHDL or a very difficult firmware expert, you can develop algorithms that are as performant, if not more performant than these, just by using a Python package that you can learn online. And then you spin it up on something like HSRML and then get it on a board reasonably quickly. And that's what's really nice about these type games is that it's just so much easier and so to get these really good algorithms out there.
But also you see the trend in the market is machine learning because there's enhancements to what we know well, and we cannot afford by A, missing the technology direction, and B, not take as much advantage as we can from its data set. So we should find a common stability to enhance the physics you can get out of high limits. And with leak opportunity, it's exciting to have to make the most of it.
So we think machine learning will eventually lead to better test performance and better physics at the end of the day. So you said the word exciting. What are you most excited about in terms of the ML?
I mean, the fact that you get all this people with all this knowledge and all this experience coming like from older experiments now, and again, all of them lining up so that they can take the most advantage out of the data set is so exciting. Like you see that, like people try to come up with thinking, try to approach ML as not like just a black box, and looking into black boxes is all about physics. This is exactly what we do. We just look under the cover and discover what we're doing, and we don't just treat it as a work as a button and all this stuff. Like
really nice. So keeping on going in this direction of machine learning being widespread use in your trigger. It's really the motivation behind the workshop, right? How do you coordinate deployment of machine learning at such massive scale? So again, question to everyone: what are some of the challenges? What are some of the solutions we propose today, and what we can see into work on in the future?
I think one of the things that we've chatted about a lot in this, because these are different issues, right? When you have tens of models you going on in your trigger once, is how do you orchestrate its set algorithms? How do you make sure that they're trading together or not relying on each other in a biased way? How do you keep track of all these models when you update one? How do you make sure you know what those updates stop? Knowing where the data came from, know where the model came from, keeping all this kind of orchestration understood, I think, is one of the big problems that we will face, and I'll probably all already face.
So the move from explicitly programmed algorithms to train algorithms really brings about operational challenges, as you said, right?
it will be, and also we have to fold early what we're gonna be defining ML in conditions that we haven't experienced before. We are going at the edge. We're going to a situation where the energy has never been before, and the physics we're going to be encountering is a physics that we haven't seen. That's a unprecedented, we're going to get new challenges and new things, and changing also the way that we're swimming with these things conditionally. It boys can an extra layer, so we have to kind of break it into small pieces and explore it one by one.
And everything else that was interesting about today was that it felt like we're kind of coming up with a strategy to push the experiment forwards. This feels like the cutting edge, the thinking that's happening at a lot of these experiments is like, how do we deal with these really advanced algorithms that we haven't really seen before? And getting everyone together, all the experts in various different places together to actually start hashing that out is great.
This was a very helpful workshop between CMS and Atlas. Knowing the faces of the other people and on the other experiment, working on the same thing with the same similar goals and with the same tools. It's very helpful, and I think it would be very good that we can just do this again and try to learn from this workshop to make it even better and continue improving the figure.
Yeah. I mean, we kind of thought about this workshop a bit differently. We didn't want it to be like a seminar style thing. How'd you take that way? Think it worked, or?
Yeah, I think more of this in the future. I actually think that at the CMS integration was kind of seamless. Like, you wouldn't be able to tell from the outside looking in it. You it's two different experiments working on two really different stacks. We really could find like the commonalities quite easily. And I think that is part of the fun that we chose to go with. Nothing too polished. Nothing. The slides were not intended to imitate that whatsoever, to imitate CMS. They were more really like to show the thought process that goes through. So I think that's a lot more valuable than showing some kind of end polished piece of art. It's going through the stage how that came to be, which is really nice. And then I guess I was just reminded that no matter how long you deliberate on something, there's always like an edge case to show thoughts out. So these workshops are really useful for that, because someone will point us out. So the more you do these, eventually I guess you cover all your bases as well. Yeah, it's really fun. Let's do that again.